The Perseverance rover has detected organic molecules on Mars that could hint at ancient microbial life forms, signals of life beyond Earth. This completely changes how we understand biosignatures found by the Perseverance rover on Mars. Here's what scientists actually discovered. As the Perseverance rover traverses the dusty plains of Mars, armed with cutting-edge instrumentation and an audacious mission, it's not just exploring the Martian landscape. It's on a quest for life itself. When scientists announced the detection of organic molecules in the Jezero Crater, it was as if a cosmic whisper had echoed across the void, igniting imaginations and challenging our notions of life's existence beyond our planet. These organic molecules, which include carbon-based compounds like amino acids and hydrocarbons, are the building blocks of life as we know it. But let's pause for a moment and unpack what this really means. Just because organic molecules have been found doesn't automatically imply that life once thrived there. In fact, it opens up a Pandora's box of scientific inquiry and debate. The excitement lies not just in what we have found, but also in what these findings infer about the Martian environment and its ancient history. To understand the significance of these discoveries, we need to step back and explore what constitutes a biosignature. Traditionally, biosignatures are defined as indicators of life. Here on Earth, we have a plethora of evidence: fossils, biochemical markers, and even atmospheric gases produced exclusively by living organisms. However, when we talk about biosignatures on Mars, the rules of the game change dramatically. The challenge lies in discerning what is a sign of life and what is merely the result of geological processes. A common misconception is that organic molecules unequivocally point to life. While they are essential components for life, they can also emerge through non-biological processes. For instance, the same molecules found in the Martian soil could have formed from volcanic activity or chemical reactions in the planet's atmosphere. Scientists have to navigate this complex interplay, relying on a combination of evidence and creative methodologies to draw conclusions. Perseverance hasn't just been idly collecting samples. It's equipped with the state-of-the-art Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals instrument. This device is akin to a forensic lab in a box, capable of analyzing the chemical composition of materials on Mars in great detail. By using Raman spectroscopy, it can identify organic compounds and their molecular structure, helping scientists determine if these compounds are indeed biological in origin. Imagine for a moment the thrill of standing in Jezero Crater, where ancient lakes once teemed with life. The rover's findings have sparked a re-evaluation of what we know about the Martian climate, suggesting that billions of years ago, Mars was not the barren desert we see today, but rather a dynamic world capable of supporting microbial life. Historical data from past missions, combined with current discoveries, are reshaping our understanding of the red planet's potential for habitability. Recent data from other missions, such as NASA's Curiosity rover and the Mars Reconnaissance Orbiter, have enriched this narrative. Curiosity has found evidence of ancient streambeds, and lake sediment, while the orbiter has mapped mineral deposits that indicate the presence of water. This accumulating evidence paints a picture of a warmer, wetter Mars in its youth, a planet where life could have flourished. Moreover, the Viking missions from the 1970s initially found a tantalizing width of organic compounds, but came up short in proving that life ever existed on Mars. Scientists suspected they had encountered biological materials, but further analysis revealed these organic compounds could be products of chemical reactions. The new findings from Perseverance lend a new perspective to these past missions. They suggest that while Viking may have missed the mark, definitely something new is happening. The evidence for life could still be hidden in the Martian soil, waiting for a more sensitive examination. Now, you might wonder how scientists are approaching this intricate puzzle. Part of the answer lies in a method known as astrobiology, a multidisciplinary field that combines biology, geology, atmospheric science, and planetary science to explore the potential for life throughout the universe. This innovative approach seeks to find commonalities between Earth and other celestial bodies, examining everything from extreme microbial life in Earth's harshest environments to the chemical processes that could lead to life elsewhere. One fascinating case study involves extremophiles, organisms that thrive in extreme conditions here on Earth, such as acidic hot springs or the icy depths of the Antarctic. The existence of extremophiles has significantly expanded our definition of habitability, suggesting that life may not require the temperate, Earth-like conditions we once assumed. This has profound implications for Mars. If life can thrive in Earth's most inhospitable places, who's to say it didn't manage to establish itself in the once warm depths of Martian lakes? Returning to Perseverance, the rover's team is not just focused on gathering data, they're also pioneers of a new era of exploration. The rover is equipped with a sample caching system designed to collect and store rock and soil samples. These samples are intended for a future mission that could return them to Earth. This ambitious plan adds another layer of excitement to our quest. Imagine the day when Martian soil could be analyzed in world-class laboratories, providing definitive answers about its past. But what does all this mean for us here on Earth? As the data rolls in and researchers ponder the implications, we're forced to reconsider our place in the cosmos. If life existed on Mars, it would challenge the unique narrative of human existence and our understanding of life's emergence in the universe. It raises profound questions. Are we alone? How many worlds may harbor life sitting just outside our view? This interplay between discovery and understanding is what makes the pursuit of knowledge so exhilarating. Each finding from Mars adds a new thread to the intricate tapestry of life's story, not just on our planet, but across the vast expanse of space. It pushes us to think bigger and deeper about our origins and the potential for life beyond our blue planet. As we continue our journey through the universe of biosignatures and the tantalizing hints of life on Mars, it's essential to recognize the marvel of scientific inquiry. Every new piece of evidence, every analytical result, brings us closer to unveiling the mysteries of our neighboring planet. In the next segment, we'll delve deeper into the tools and technologies that are revolutionizing how we explore planets beyond our own, and how they change our understanding of life in the universe. Stay tuned, because the story of Mars is just beginning. The discovery of organic molecules on Mars is shaking the foundation of our understanding of life beyond Earth. This completely changes how we perceive the potential for extraterrestrial life. Here's what scientists actually discovered. The Perseverance rover, a marvel of human engineering, has been traversing the Martian landscape since February 2021, exploring the Jezero Crater, a site believed to have once been an ancient lake. With an array of cutting-edge instruments, Perseverance is not just searching for signs of life, it's rewriting the narrative of what we believe about the potential for life on other planets. Among the most staggering findings of the mission are biosignatures, which are essentially indicators that life may have existed in some form in the past. So what exactly are these biosignatures? In simple terms, they are the chemical fingerprints left behind by living organisms. The rover has detected organic compounds, including carbon-based molecules, which are the building blocks of life as we know it. These findings are monumental because they suggest that Mars might have had the right conditions to host microbial life billions of years ago. But before we dive deeper into the implications of these discoveries, let's explore what biosignatures entail and how they can reshape our understanding of Mars and the greater cosmos. Section: The Chemistry of Life. At the heart of the biosignature search on Mars is carbon, which forms the backbone of all known life on Earth. In the process of examining samples, Perseverance has identified complex organic molecules, including aromatic hydrocarbons, a hallmark of biological activity. These compounds were detected using the rover's scanning habitable environments with Raman and luminescence for organics and chemicals. Sherlock instrument, which uses laser technology to identify minerals and organic compounds on a molecular level. Interestingly, these organic molecules do not necessarily indicate that life existed on Mars. They can also arise from non-biological processes. For instance, cosmic rays and ultraviolet radiation can create organic compounds through interactions with Martian soil. This duality is crucial for scientists as they work to differentiate between abiotic and biotic origins of these molecules. This leads us to a fascinating historical context. The ancient Greeks were among the first to ponder the possibility of life beyond Earth. Philosopher Anaxagoras proposed that life existed throughout the universe. Fast forward to the present, and we see how the scientific method has advanced our understanding far beyond philosophical speculation. It's a powerful reminder that the search for extraterrestrial life is a journey that spans centuries, with each discovery building on the last. While organic molecules provide potential clues to life, Mars's geology also tells a compelling story. The Jezero Crater, where Perseverance landed, is rich in sedimentary rock, which is formed from the accumulation of particles in a liquid environment. This lakebed likely harbored microscopic life forms when it was filled with water over 3 billion years ago. As scientists analyze the geological formations, They employ techniques similar to those used in archaeological digs on Earth. For instance, they look for stratification in the rock layers, which can reveal the environmental conditions that existed at different times. Understanding the sedimentary record is critical, as it allows researchers to piece together the history of water on Mars and its potential habitability. Moreover, Perseverance's findings can be compared to ancient Earth environments. The discovery of biosignatures in similar sedimentary deposits on Earth, such as the ancient lakes in Western Australia, provides a framework to interpret what we find on Mars. This connection is an excellent example of how modern science bridges what we know about our own planet with the mysteries of others. Myth versus reality of Martian life. A plethora of misconceptions surrounds the idea of life on Mars. One of the most persistent myths is the notion of Martian aliens, as depicted in science fiction. These portrayals lead to a sensationalized view that often oversimplifies the complexities of finding life. The reality is that the search for life on Mars is focused on microbial organisms, simple life forms that could have existed in the planet's distant past. In fact, many scientists theorize that if life existed on Mars, it may have been similar to extremophiles found on Earth, microorganisms that thrive in extreme conditions such as deep-sea hydrothermal vents or acidic lakes. These organisms can survive in environments that were previously deemed uninhabitable, which expands our understanding of the possibilities for life in harsh extraterrestrial environments. The implications of discovering microbial life on Mars are profound. It would not only affirm that life could arise independently on different planets and therefore could be common in the universe, but it would also challenge our understanding of life's resilience. Such findings compel us to reconsider our definitions of life and the conditions required for its existence, ultimately urging us to explore other celestial bodies with renewed vigor. The method behind the madness. Understanding how we gather and analyze data from Mars is as crucial as the data itself. The methodologies employed in planetary science are intricate and multifaceted, combining various disciplines, including chemistry, geology, and biology. Perseverance is equipped with a suite of scientific instruments that allow it to conduct experiments and analyze its surroundings directly. One approach includes the use of the SuperCam, which utilizes a laser to analyze the composition of Martian rocks and soil. This technique allows scientists to identify minerals and assess their potential for containing biosignatures. By employing multiple methods of analysis, researchers can cross-verify findings, a standard scientific practice that bolsters the reliability of results. Moreover, the rover's ability to collect samples for future return missions adds another layer of intrigue. These samples will allow scientists to perform in-depth analyses back on Earth, where sophisticated laboratories can utilize advanced techniques not feasible on the Martian surface. The prospect of Martian samples arriving on Earth is akin to an archaeological dig where artifacts from an ancient civilization are brought to light, sparking new questions and insights. Patterns of life and the ancient connection. As we delve deeper into the implications of the Perseverance rover's findings, we must also consider the broader patterns of life in our universe. The The study of astrobiology seeks to unlock the secrets of life beyond Earth by examining the conditions required for life to thrive. This involves analyzing environments on other celestial bodies, such as the icy moons of Jupiter and Saturn, where subsurface oceans may harbor life. Interestingly, the quest for understanding Martian biosignatures aligns with ancient cultures' perspectives on the cosmos. Many civilizations, such as the Egyptians and the Mesopotamians, held beliefs about the stars and planets, viewing them as deities or as part of a larger cosmic order. Their mythologies often intertwined with the natural world, reflecting a keen interest in understanding their environment, an early form of scientific inquiry. Modern science mirrors this ancient curiosity as we seek to understand our place in the universe through the lens of evidence and exploration. The connection between ancient knowledge and contemporary scientific endeavors is remarkable, illustrating how humanity's quest for understanding transcends time. Conclusion: an ongoing journey. As we continue to analyze the data sent back by the Perseverance rover, we are reminded that the quest for understanding Mars, and potentially other worlds, will be a long and intricate journey. Each discovery is a piece of a larger puzzle that will ultimately reshape our understanding of life and the universe itself. The findings of biosignatures are not just scientific data. They are a call to exploration, a challenge to our perceptions, and a doorway to future discoveries. In the coming segments, we'll dive deeper into the detailed findings from the Perseverance rover, engaging with the latest research, exploring what future missions may reveal, and connecting these developments to our ever-evolving understanding of life beyond our planet. As we explore further, we invite you to join us on this journey of discovery, excitement, and intellectual wonder. Did you know that the Perseverance rover has been searching for biosignatures on Mars, and scientists believe it may have found evidence of ancient microbial life? This completely changes how we understand the potential for life beyond Earth. Here's what scientists actually discovered. As the Perseverance rover traverses the dusty, rust-hued surface of Mars, it's not just a mechanical marvel making tracks across a foreign planet. It's a time machine, equipped with state-of-the-art instruments designed to unlock secrets that have lain dormant for billions of years. Among its most thrilling missions is the quest for biosignatures, indicators that may suggest the past presence of life. This is not just a hunt for fossils. It's a journey that reveals how interconnected our understanding of life on Earth is with the broader cosmos. Fascinating discoveries in the Atacama Desert. To understand how Perseverance is searching for biosignatures, it's essential to look at the cutting-edge scientific methods utilized, which have their roots in earthbound research. For instance, scientists have drawn parallels between the Martian landscape and extreme environments on Earth, particularly places like the Atacama Desert in Chile. This desert is one of the driest places on Earth, yet it hosts microorganisms that have adapted to survive in harsh conditions. The Atacama's unique geology and climate offer a model for scientists studying Mars. By examining the biosignatures these extremophiles leave behind in such a hostile environment, researchers can refine their search strategies for similar signatures on Mars. This cross-pollination of knowledge highlights an astonishing connection. the same elements that allow life to thrive in unforgiving terrains on Earth may also hint at the past existence of life on other planets. For instance, in their studies, researchers discovered microbial mats in the Atacama, which are formed by layers of microorganisms. These mats leave behind a fossilized record containing carbon isotopes that signify biological activity. When Perseverance samples ancient Martian rock formations, it does so with this knowledge in mind, searching for analogous microbial signatures that may have emerged billions of years ago when Mars had a more hospitable climate. The role of advanced instruments. Perseverance is equipped with an array of instruments that allow it to analyze soil and rock samples in real time. The scanning habitable environments with Raman and luminescence for organics and chemicals. Sherlock instrument, for example, uses laser technology to identify organic compounds down to the molecular level. This capacity to detect subtle clues about potential past life is unprecedented. But how do scientists differentiate between organic materials that signify life and those that are simply chemically produced? This is where a deeper understanding of molecular biology comes into play. The unique arrangements and isotopic compositions of organic molecules found in biosignatures can often point to biological origins. For instance, many biological molecules on Earth use carbon-12 isotopes in a specific ratio, which would differ from non-biological sources. This endeavor is not without its challenges. For years, scientists have had to confront misconceptions about what constitutes definitive biosignatures. A common fallacy is equating the presence of simple organic molecules with signs of life. However, the mere existence of carbon compounds does not inherently indicate biological activity. By employing sophisticated techniques, Perseverance is at the forefront of redefining these boundaries, allowing scientists to sift through Martian materials with a discerning eye. The scientific process, from hypothesis to discovery. To frame Perseverance's findings, it's vital to consider the scientific process itself, an iterative journey of hypothesis, experimentation, and repeated validation. This methodology is as old as science itself, yet it's continually shaped by new discoveries. Take, for instance, the historical search for early life on Earth. Over the decades, researchers have unearthed ancient stromatolites, layered structures created by microbial communities that provide compelling evidence of life over 3 billion years ago. The ongoing analysis of these ancient formations has reshaped our understanding of life's resilience and adaptability. This historical context is crucial as it informs our search for similar structures or patterns on Mars. What if Perseverance discovers formations resembling stromatolites? Such a finding would not only elevate our understanding of Martian geology, but also redefine the timeline and conditions under which life could potentially arise elsewhere in the universe. Further, this iterative process encourages a diverse set of perspectives. The interplay between geology, biology, and even chemistry has fostered a holistic approach to understanding life beyond our planet. The more collaborative we become, merging fields like astrobiology, planetary geology, and even anthropology, the more intricate the tapestry of knowledge we weave about life's potential in the cosmos. Cultural practices and ancient knowledge, a scientific lens. As we delve deeper into the implications of finding biosignatures on Mars, it's fascinating to consider how ancient cultures on Earth have regarded the cosmos. Many civilizations looked to the stars and planets, weaving intricate myths and stories about their origins. For instance, ancient Mesopotamians viewed the night sky as a canvas painted by the gods, believing that celestial events influenced earthly occurrences. Connecting these cultural narratives to modern scientific inquiry is more than just an intellectual exercise. It's a reminder of humanity's enduring curiosity. The ancient Greeks, with their rich mythology, often pondered the existence of life beyond Earth. They laid the philosophical groundwork that would eventually give birth to the scientific method, urging future generations to question and explore. Today, as Perseverance roams the Martian surface, scientists are not only searching for biosignatures, they are also echoing the ancient yearning for understanding the cosmos. The discoveries made by the rover could potentially rewrite narratives about life across cultures and time. Should we find definitive evidence of past microbial life, it may lead to a renaissance in how we conceptualize our place in the universe, a blend of science and philosophy that echoes the sentiments of our ancestors, challenging popular misconceptions. As exciting as it is to contemplate the discovery of biosignatures, there remains a critical need to challenge popular misconceptions about life on other planets. One of the prevailing myths is the idea that only Earth-like conditions can support life. However, the discovery of extremophiles on Earth has broadened the scope of what we consider habitable environments. From hydrothermal vents in the depths of the ocean to the icy landscapes of Antarctica, life persists in astonishingly diverse conditions. Mars, once believed to be a barren wasteland, is now considered a candidate for having harbored life due to its past conditions. Scientists theorize that, billions of years ago, Mars featured rivers, lakes, and perhaps even oceans, conditions remarkably conducive to life. Thus, the very fabric of how we define habitability is unraveling and being rewritten. Perseverance's findings may challenge our perceptions further. What if, instead of finding familiar forms of life, we discover entirely unique biosignatures that defy our current understanding? This would not only revolutionize astrobiology, but also compel us to reassess our definitions of life itself. The fascinating patterns of cosmic chemistry. At a higher level, the search for biosignatures also exposes fascinating patterns in cosmic chemistry, suggesting that the building blocks of life are widespread in the universe. The existence of organic molecules in comets, meteorites, and even the interstellar medium indicates that the ingredients for life are not limited to our planet. Take, for example, the recent advancements in our understanding of meteorites, particularly those that contain amino acids, nature's building blocks of proteins. This evidence strengthens the hypothesis that life's components may be more common than previously thought. Now, with Perseverance analyzing Martian rocks that may harbor similar compounds, we stand at the precipice of a potential cosmic revelation. Could life have been seeded across the solar system through meteorite impacts? The idea itself is awe-inspiring. Picture this: a comet traversing the vast emptiness of space, carrying inside it the seeds of life, colliding with a young, volcanic Mars. Such collisions could have provided the necessary elements for life to emerge in its earliest stages. This perspective of cosmic interconnectedness not only enhances our understanding of life's origins on Earth, but also places humanity within a grander narrative of the universe, a narrative alive with possibility, connecting ancient knowledge to modern discoveries. In contemplating these scientific revelations, it's essential to draw connections between ancient knowledge systems and modern discoveries. Many indigenous cultures has long understood their place within a broader cosmic framework, often attributing spiritual significance to celestial bodies. They viewed the stars as ancestors or guides, shaping their understanding of life and existence. Now, as we reach out into the cosmos with tools like perseverance, we begin to bridge the gap between empirical science and these ancestral perspectives. The search for biosignatures on Mars is not just about finding evidence of life. It is about unearthing the stories that connect us to the universe. Imagine a future where we find, against all odds, a biosignature on Mars. This discovery would not merely be a scientific triumph. It may rekindle ancient wisdom, prompting us to reflect on our origins and our interconnectedness with the universe. The journey of perseverance embodies this quest, not just to answer the age-old question of "Are we alone?", but to remind us of the narratives that define our humanity. As we continue to analyze the data sent back from the rover, we can only imagine the stories hidden beneath the Martian surface, waiting to be uncovered. Each sample, each analysis, serves as a stepping stone towards a deeper understanding of life's potential across the cosmos. With every discovery, we inch closer to unraveling the grand tapestry of existence, where ancient myths, modern science, and the desire for understanding converge. This scientific adventure transcends mere exploration. It reflects a profound curiosity that is uniquely human, a desire to know, to connect, and to learn from the past as we reach for the stars. The Perseverance rover may be our most advanced tool yet, but it is also a symbol of our collective quest for knowledge. A journey that has spanned millennia and will undoubtedly shape generations to come. As we continue our exploration of Mars and the potential biosignatures within, there is no telling what we may uncover next. The universe is vast and filled with mysteries, and each piece of evidence we gather propels us further along this awe-inspiring journey. What lies beneath the Martian surface? What stories await us in the cosmos? Only time, and perhaps a little bit of perseverance, will tell. Did you know that the Perseverance rover, which landed on Mars in February 2021, has already discovered evidence that could suggest the presence of ancient microbial life? This completely changes how we understand our neighboring planet and the possibility of life beyond Earth. Here's what scientists actually discovered. As Perseverance navigates the Martian landscape, it's not just a high-tech vehicle, it's a time capsule, excavating clues that may tell us about a different epoch of our solar system, an epoch when Mars was much more Earth-like. Among its many tasks, Perseverance is meticulously analyzing samples for biosignatures, which are signs of life, past or present. One of the most groundbreaking findings from the rover is its analysis of the Jezero Crater. This ancient lakebed, rich in sedimentary deposits, is believed to have been formed over 3 billion years ago, when water flowed freely across Mars. The rover has collected rock samples that show layered sedimentary deposits, reminiscent of those found in Earth's own fossil-rich basins. But what does that mean for the search for life? Recent studies of terrestrial sedimentary rocks reveal that they often harbor biosignatures, tiny remnants of microorganisms that lived in those environments billions of years ago. When scientists analyze these rocks, they can discern patterns and chemical markers that indicate biological activity. If similar markers are found in the samples collected by Perseverance, it could signify that Mars, too, was once teeming with life. Despite popular misconceptions that Mars is an inhospitable wasteland, the reality is far more intriguing. Evidence suggests that ancient Mars had rivers, lakes, and possibly even oceans. Scientists believe that if life ever existed there, it could have thrived in these watery environments. This challenges the notion that life can only flourish in specific conditions and opens the door to the possibility that life could exist in similarly harsh environments elsewhere in the universe. And how exactly does Perseverance go about this monumental task? The rover is equipped with a suite of scientific instruments designed for astrobiological exploration. One of its key tools, the scanning habitable environments with Raman and luminescence for organics and chemicals, Sherlock, uses a method known as Raman spectroscopy. This technique involves shining a laser on the Martian rocks and analyzing the light that bounces back. The unique fingerprint of the light can reveal the molecular structure of the materials present, offering vital clues on whether organic molecules, key ingredients for life, are present. The findings are particularly exciting when we consider how ancient peoples viewed the cosmos. The Babylonians, for example, meticulously charted the movements of celestial bodies thousands of years ago, while infusing their astronomical observations with mythology. They believed planets were the manifestations of their gods, a fascinating blend of science and spirituality that echoed their understanding of the world around them. Fast forward to today, and we see a modern parallel in how we approach Mars exploration. The scientific methodologies used now bear striking resemblances to ancient practices, but are backed by advanced technology and rigorous experimentation. Just as early astronomers sought to understand the skies, today's scientists are peering deeper into the question of life in the cosmos through missions like Perseverance, expanding our understanding of life's potential forms and habitats. One of the most compelling aspects of this journey is how modern science continually reshapes our understanding of the past. Take, for instance, the recent discovery of ancient Martian minerals like carbonates and sulfates in Jezero Crater. These minerals often form in the presence of water, hinting at a time when the Martian surface was warm and wet. Scientists have long debated whether Mars ever had the right conditions for life. But the presence of these minerals suggests that, at least at one point, it did. This revelation connects to another line of inquiry: the geological processes that have shaped both Earth and Mars. The study of sedimentology helps scientists understand how environments evolve over time and how life adapts to changing conditions. The patterns observed in Martian rocks can lead to insights about ancient Earth, where similar processes were at play. Moreover, as Perseverance collects rock samples, it's not just gathering data for itself, it's paving the way for future missions that may return these samples to Earth. The potential to analyze Martian rocks in terrestrial laboratories could revolutionize our understanding of astrobiology. Scientists will be able to apply advanced techniques to investigate biosignatures that might be elusive in situ, deepening our comprehension of life's origins. But why is the search for biosignatures so essential? It reaches far beyond the thrill of discovery. It addresses fundamental questions about our existence. Are we alone in the universe? Are there other forms of life that may not resemble what we know? These inquiries drive scientific exploration and reflect humanity's enduring fascination with the cosmos. As we unravel the mysteries of Mars, we also reflect on the historical context of our curiosity about extraterrestrial life. The ancient Greeks engaged in philosophical debates about the possibility of life beyond Earth. Thinkers like Aristotle pondered the nature of the universe and humanity's place within it. Their ideas, though based on limited information, laid the groundwork for modern scientific inquiry. Back to the present, Perseverance's analysis extends beyond just finding ancient microbes. It's also about understanding the environmental conditions that could sustain life. The rover's instruments measure atmospheric composition, analyze soil samples, and search for organic molecules. This multifaceted approach is akin to how early alchemists and natural philosophers sought to understand the world, though in a far more rigorous and systematic manner. Interestingly, the search for biosignatures also dovetails with contemporary discussions about climate change and sustainability on Earth. By examining Mars's past climates and geological changes, scientists hope to learn valuable lessons about planetary health and resilience. In a sense, Mars offers a cautionary tale of what can happen when a planet's environment shifts dramatically. His perspective shifts our view of Mars from a barren, lifeless rock to a vital piece of our broader cosmic puzzle. Just as ancient civilizations learned from their surroundings, modern science teaches us about the delicate balance of ecosystems. The exploration of Mars emphasizes the interconnectedness of life and environment, a theme that resonates throughout human history and underscores our responsibility to care for our planet. As we contemplate those findings, the implications are profound. What if the biosignatures found on Mars challenge our very conception of life? Would we be ready to accept that life can thrive in forms we cannot yet comprehend? This echoes the revolutionary ideas of scientists like Charles Darwin, whose theories on evolution reshaped our understanding of biology. The potential discovery of life on Mars could lead to a paradigm shift, much like Darwin's work did in the 19th century, and it doesn't stop there. The scientific community is buzzing with excitement and speculation about what else Perseverance might uncover. The rover has prioritized locations with high potentials for biosignatures, and its findings will undoubtedly provoke debates and discussions that will shape future explorations. Each discovery raises more questions, propelling scientists deeper into the unknown. There's also a fascinating cultural dimension to this exploration. The idea of extraterrestrial life has been woven into narratives throughout human history. From ancient myths to modern science fiction, the allure of the unknown continues to inspire art, literature, and philosophy. This interplay between science and culture highlights a fundamental human desire to explore and understand the universe. As we draw connections between ancient knowledge and modern discoveries, we see a beautiful tapestry of understanding being woven. Each thread, from the myths of old to the cutting-edge technology of today, adds depth to our narrative as a species striving for knowledge. Just as the Babylonians used the stars for navigation and timekeeping, we now look to Mars for understanding our place in the cosmic landscape. But let's not forget about the very real challenges that lie ahead. As Perseverance continues its mission, the quest for funding, international collaboration, and ethical considerations surrounding planetary exploration raise important discussions in the scientific community. How do we balance exploration with preservation? What responsibilities do we have toward other celestial bodies and potential life forms? These questions underscore the need for a thoughtful and collaborative approach to space exploration. By learning from our past, both in terms of earthly civilizations and our scientific endeavors, we can navigate the complexities of our journey into the cosmos more responsibly and with greater respect for the universe. With each passing day, as Perseverance sends back data, we inch closer to answering some of our most profound questions. The quest for biosignatures on Mars is not just about finding life. It's about understanding the broader narrative of existence, the interplay of life and environment, and our ongoing journey of discovery. So, as we continue this fascinating exploration, remember that the search for life on Mars is a testament to human curiosity, a reflection of our ancient past, and a beacon of hope for the future. Each finding, each sample collected, seeds not just our scientific understanding, but also our inherent desire to connect with something greater than ourselves. In the chapters that follow, we'll delve deeper into the potential implications of these discoveries and explore what they mean not just for Mars, but for Earth and humanity as a whole. The story of Perseverance is just beginning, and as we continue this journey together, let's keep our minds open to the wonders that await us. Stay tuned, because the next discoveries could change everything we think we know about life beyond our planet. And while you're here, if you're enjoying this captivating exploration of Mars and the search for biosignatures, consider joining us as we continue to delve into the mysteries of the universe. Your enthusiasm fuels our journey into the unknown, and we can't wait to share more discoveries with you. It's a common misconception that Mars is a desolate wasteland, completely devoid of life. In fact, recent discoveries made by the Perseverance rover have thrown open the door to a dazzling new understanding of our planetary neighbor. Just a few months ago, scientists announced some astonishing biosignatures detected in Martian rock samples. This completely alters our perception of what Mars might have once been like, and suggests the tantalizing possibility that life could have existed there. Here's what scientists actually discovered. The Perseverance rover, a marvel of modern engineering, embarked on its mission with a clear goal: to search for signs of ancient microbial life on Mars. Positioned in Jezero Crater, an area that once housed a vast lake, Perseverance is equipped with cutting-edge technology designed to analyze the Martian surface and atmosphere. Among its most groundbreaking findings are organic molecules, complex carbon-containing compounds that are fundamental to life as we know it. These compounds were detected in sedimentary rock layers, echoing the sort of geological formations we associate with life on Earth. But before we dive deeper into these findings, let's put this in a broader context. The search for life beyond Earth has been a dream of humanity for centuries, from the ancient Greeks contemplating the stars to the modern scientific endeavors like the Mars exploration program. Our desire to understand our place in the universe is a constant thread in human history. Yet, what does the evidence from Perseverance truly tell us about Mars, and by extension, about life itself? One particularly fascinating aspect of the findings revolves around the concept of biosignatures. A biosignature is any substance, such as an element, isotope, molecule, or phenomenon, that provides scientific evidence of past or present life. On Mars, Perseverance found a range of organic compounds, some of which are considered potential biosignatures. These compounds, while not definitive proof of life, invite us to reconsider the ancient environments of Mars. In the early years of Mars exploration, many scientists believed the planet was too harsh for life. The prevailing narrative was that it was a sterile environment, shaped solely by its geology and climate. However, as technology advanced and our understanding deepened, new methodologies emerged. Scientists began to employ sophisticated techniques like spectroscopy and mass spectrometry to analyze Martian rocks and soils. This shift enabled researchers to detect not just simple molecules, but also complex organic compounds, which can be produced by biological activity. Let's take a moment to appreciate the significance of these findings. The detection of organic molecules on Mars does not mean we have found life yet. However, it does suggest that the building blocks of life are present, potentially indicating that ancient Mars had the right conditions to support life. This is akin to finding fossils in a distant land. They do not bring the creatures back to life, but they tell us that life once thrived in that environment. Interestingly, the cultural implications of these discoveries tie back to humanity's long-standing fascination with life beyond Earth. Ancient civilizations often envisioned life on other celestial bodies, weaving myths and legends that explored these concepts. For example, the Sumerians believed in the Anunnaki, deities that descended from the heavens, influencing the earth. Fast forwarding to today, our evolving understanding of Mars, through the lens of scientific discovery, reflects a new narrative, one where life may not be exclusive to Earth. To fully grasp the implications of these organic molecules, we need to delve into the methodology employed by Perseverance. The rover's instruments systematically analyze Martian rock samples, searching for patterns that could suggest biological processes. For instance, the Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals instrument, uses lasers to identify specific organic compounds and minerals. This sophisticated technology has allowed scientists to detect the presence of carbonates and sulfates, minerals that often form in the presence of water, an essential ingredient for life. The discovery of these minerals in Jezero Crater adds layers of complexity to our understanding of ancient Martian environments. Water, once flowing in rivers and lakes, could have created habitats conducive to life. These findings also provide a stark reminder of how geological processes can mirror the conditions necessary for life, illuminating patterns that bridge the ancient and the modern. As we ponder the implications of these discoveries, it's essential to address some common misconceptions. Many people assume that if we find organic molecules, it equates to the existence of life. While organic molecules are indeed the building blocks of life, their mere presence does not confirm life itself. They can also arise from abiotic processes, those not associated with living organisms. This distinction is crucial, as it leads us to consider alternative explanations for the origins of these molecules. The potential for ancient microbial life on Mars compels us to reflect on Earth's own history. Our planet has undergone radical transformations over billions of years, with life emerging in the most unexpected places. From extremophiles thriving in deep-sea vents to organisms living in acidic lakes, life's tenacity is evident. Understanding how life can adapt and flourish in extreme environments here on Earth serves as a guide for our exploration of Mars and other celestial bodies. Moreover, the Perseverance mission continues to build on the knowledge gleaned from previous Mars missions, such as Curiosity and Opportunity. Each rover has contributed invaluable data, creating a mosaic of Martian history. For example, Curiosity discovered clay minerals that form in water, suggesting that Mars once had a wet environment. These correlations across missions illustrate the scientific pattern of building knowledge incrementally, much like the way ancient cultures accumulated wisdom over generations. In the realm of archaeology, similar methodologies are employed to unlock the mysteries of human history. Archaeologists rely on stratigraphy, analyzing soil layers to determine the chronological sequence of events in a given site. Understanding the context of an artifact or a fossil within these layers allows researchers to reconstruct past environments and cultural practices. Similarly, Perseverance operates on a stratigraphic principle, analyzing the layers of Martian geology to unveil the planet's past. One might wonder how ancient knowledge intersects with these modern discoveries. ancient civilizations, guided by their observations of the cosmos, often predicted celestial events and charted stars. This pursuit of understanding mirrors today's scientific inquiries into the universe. For instance, the Mayans astutely observed planetary movements and cyclical phenomena, leading to impressive astronomical calendars. The alignment of modern scientific exploration with ancient wisdom underscores a timeless curiosity that connects humanity across millennia. As we contemplate the discoveries made by Perseverance, we must also consider the broader implications for humanity as we seek to understand our role in the cosmos. The possibility of past life on Mars raises profound questions. What does it mean to be alive? How do we define life? These inquiries are not only scientific, but also philosophical, inviting us to explore our place in the universe. The future of Martian exploration is illuminated by the successes and challenges of the Perseverance rover. As it continues to collect samples, the potential for groundbreaking finds remains high. Scientific teams back on Earth eagerly await the rover's return to analyze these samples in unprecedented detail. This integration of modern science with historical inquiries demonstrates a commitment to unraveling the truths of our solar system, echoing the ancient quests for knowledge that have characterized humanity throughout time. In this ongoing dialogue between history and science, the discoveries on Mars remind us of our own planet's evolution and the myriad forms life can take. As we uncover the secrets of our neighboring planet, we gain not only insights into Mars itself, but also a deeper understanding of Earth's own past and future. Stay tuned as we continue to explore more extraordinary findings from the Perseverance mission. The narrative of Mars is still unfolding, filled with intrigue and wonder, a testament to the enduring human spirit of exploration and discovery. In the next segment, we will delve into another groundbreaking aspect of Mars exploration that has the potential to reshape our perceptions and ignites the fire of scientific inquiry. But before we conclude this fascinating chapter, consider this. What if the findings on Mars are just the beginning of a new era of discovery? What if we're on the cusp of rewriting not only the history of Mars, but also our understanding of life itself? The possibilities are as boundless as the universe, and with each revelation, we inch closer to a deeper comprehension of the cosmos and our place within it. As we wrap up this segment, remember that science is not just a collection of facts. It is a dynamic process of discovery, questioning, and understanding. As we continue to explore realms beyond our own, we foster a sense of connection, bridging the ancient and the modern, the known and the unknown. So join me in the next part of our journey as we unravel more of the mysteries that await us on Mars and beyond. One shocking fact that immediately hooks: did you know that the very soil on Mars may contain ancient biosignatures, possibly hinting at life that existed billions of years ago? This completely changes how we understand our neighboring planet and the potential for extraterrestrial life. Here's what scientists actually discovered with the Perseverance rover. As the Perseverance rover rolls across the Martian landscape, its mission transcends the mere act of exploration. It is a quest to decipher the history of life on another world. The rover has been equipped with an array of sophisticated instruments designed to analyze the composition of Martian soil and rocks. And it has already begun to uncover tantalizing clues that could reshape our understanding of life in the cosmos. One of the most compelling discoveries comes from the rover's use of its onboard sample caching system. This innovative technology allows Perseverance to collect and store soil samples for future return missions to Earth. Imagine holding a piece of Mars in your hands. But why does this matter? The answer lies in a unique aspect of biochemistry: biosignatures. These are materials, such as organic molecules or isotopic patterns, that provide evidence of past life forms. Chapter 2. What exactly are these biosignatures? They are like fingerprints left behind by life, telling a story of organisms that once thrived in an environment. On Earth, scientists have identified biosignatures in ancient rocks that date back billions of years, revealing a rich history of microbial life. The search for similar signs on Mars has intensified since Perseverance's landing in February 2021, and early results are promising. In one of its recent analyses, Perseverance found intriguing organic molecules in Martian rocks. While the presence of organic compounds alone doesn't confirm life, after all, they can be created through non-biological processes. It raises the tantalizing possibility that life could have existed. The rover's findings suggest that the Jezero Crater, where it landed, was once a lake bed with conditions favorable for life. This ancient lake is believed to have existed during a time when Mars had a thicker atmosphere and liquid water flowing freely on its surface. Historical perspectives on life beyond Earth. The search for extraterrestrial life is not a new endeavor. Throughout history, various cultures have pondered the existence of life beyond our planet. Ancient philosophers like Aristotle speculated about the possibility of other worlds, while the advent of telescopes in the 17th century sparked a more scientific inquiry into the cosmos. Fast forward to the 20th century, when works like Carl Sagan's Cosmos ignited public interest in the possibility of life on other planets, laying the groundwork for modern astrobiology. As we look back, it's fascinating to see how these historical discussions laid the groundwork for today's scientific methodologies. The idea that Mars could harbor signs of ancient life is rooted in both cultural curiosity and empirical investigation. This intersection of science and history illustrates how our quest for knowledge evolves, reflecting our growing understanding of the universe. When Perseverance identifies potential biosignatures, it relies on techniques such as Raman spectroscopy, X-ray fluorescence, and even the analysis of isotopic ratios. Take Raman spectroscopy, for instance. This technique involves shining a laser onto a sample and observing how the light scatters. Different materials will scatter light in unique ways, allowing scientists to identify the molecular structure of compounds present. This method is particularly invaluable in searching for organic compounds and minerals that might signify past biological activity. Moreover, The rover also utilizes the SuperCam, which combines a laser with a camera to analyze rock compositions from a distance. This capability is essential for identifying areas that warrant further investigation, allowing scientists to prioritize locations that are most likely to yield biosignatures. Misconceptions about Martian life. Despite the excitement surrounding the search for biosignatures, several misconceptions persist. One common myth is that Mars is a barren wasteland with no potential for life. While its surface conditions today are harsh, with extreme temperatures and high radiation, evidence suggests that Mars was once a much more hospitable environment. The presence of ancient riverbeds, lake deposits, and mineral formations, indicative of water, traces back to a time when Mars could have supported microbial life. Another misconception is that the search for life on Mars is simply a matter of finding complex organisms. In reality, scientists are primarily focusing on detecting microbial life. Microbes played a crucial role on Earth, driving the planet's biochemical cycles for billions of years. Finding evidence of past microbial life on Mars would be monumental, as it would indicate that life can emerge in diverse environments across the universe. Cultural practices and scientific insights exploring the ancient history of Mars also sheds light on how cultures on Earth have understood the existence of other worlds. Many indigenous cultures have rich mythologies about celestial bodies. The ancient Greeks, for example, imagined planets as deities, embodying various aspects of life. These stories reflect the human desire to connect with the cosmos, a thread that continues today as we seek to understand our place in the universe through scientific inquiry. Interestingly, this cultural perspective is echoed in modern scientific practices. Ethnobotanists study how indigenous people utilize local flora and fauna, which can inform contemporary science regarding biodiversity and ecosystems. Similarly, astrobiologists draw inspiration from life forms that thrive in extreme environments on Earth, such as deep-sea vents or the icy regions of Antarctica, to inform their search for life on Mars. This interplay highlights the importance of interdisciplinary approaches in understanding life's potential, both on our planet and beyond. Connections between ancient knowledge and modern discoveries. The quest for life on Mars is also a testament to the continuity of scientific exploration. The methodologies we employ today are built upon centuries of inquiry, from the ancient Egyptians, who meticulously documented their astronomical observations, to the Renaissance thinkers who revived interest in heliocentrism. Each era has contributed to our current understanding of life and the universe. Modern discoveries, such as the potential biosignatures on Mars, echo these ancient pursuits. The idea that life might exist elsewhere is not merely a modern fantasy. It is a question that has captivated humanity throughout history. The distinction lies in our ability to pursue these questions through scientific methods that yield empirical evidence. As we uncover more about Mars, we are not just exploring a distant planet. We are tracing the lineage of human curiosity, the patterns of life through time. As the Perseverance rover investigates Martian soils, scientists are also examining how patterns of life emerged on Earth, providing context for the findings on Mars. The theory of panspermia, which suggests that life may have originated from microorganisms traveling through space, raises intriguing questions about the interconnectedness of life throughout the cosmos. If Mars did host microbial life in its past, could it have shared genetic material with Earth, or even vice versa? This concept is supported by recent discoveries of extremophiles, organisms that thrive in harsh conditions on Earth, suggesting that life is more resilient than previously thought. The implications are profound. If life can adapt and survive in the most inhospitable environments, then the potential for life elsewhere, including on planets like Mars, becomes increasingly plausible. The implications of discoveries. The implications of the discoveries made by Perseverance extend beyond the realm of science. They challenge our perceptions of life and existence. If we find definitive evidence of past life on Mars, it will not only reshape our scientific understanding, but will also provoke philosophical and ethical discussions. What does it mean for humanity to share a cosmic neighborhood with other life forms? How will it affect our understanding of life's origins and our place in the universe? In addition to these profound questions, the ongoing research into Martian biosignatures also prompts a re-evaluation of Earth's environmental history. The study of extraterrestrial life could help us better understand past climate changes on our planet, providing insights into our own ecological challenges. Hashtag interdisciplinary approaches in understanding biosignatures. As we unravel these mysteries, the importance of interdisciplinary collaboration becomes clear. Astrobiologists, geologists, chemists, and historians must work together to piece together the complex puzzle of life's existence on other planets. Each discipline offers unique perspectives and methodologies that are vital in forming a comprehensive understanding of our universe. For instance, by combining geological studies of Mars with the data collected from the rover, scientists can reconstruct ancient environments and assess their habitability. This geoscience approach complements biological studies, illuminating how ancient life forms might have adapted to their surroundings. Additionally, insights gained from studying biosignatures on Mars can inform our understanding of life on Earth. By examining how life has thrived in various contexts, we can gain a deeper appreciation for the delicate balance that sustains our planet's ecosystems. This interconnectedness underscores the idea that our quest for knowledge is not confined to one planet, but encompasses the larger tapestry of life in the universe. Hashtag the future of Mars exploration. As we look to the future, the discoveries made by Perseverance are just the beginning. Future missions are already being planned to return samples from Mars to Earth, allowing for even more in-depth analysis. The possibility of re-examining these biosignatures in our laboratories holds the potential for groundbreaking discoveries. Moreover, the ongoing advancements in technology and scientific techniques promise to enhance our understanding further. The integration of artificial intelligence in analyzing vast datasets could expedite the identification of potential biosignatures, allowing for real-time assessment of findings. In the grand narrative of humanity's search for life in the universe, the exploration of Mars represents a pivotal chapter. We are not merely visiting a barren planet. We are exploring our shared cosmic heritage, seeking answers to the questions that have echoed through the ages. Each discovery made by Perseverance serves as a reminder of our connection to the universe and the enduring human spirit of exploration. Conclusion: a journey of discovery. As we journey through this fascinating narrative, the search for biosignatures on Mars offers not only scientific wonder, but also a reflection of our collective quest for understanding. Each finding encourages us to look beyond our earthly confines and consider the broader implications of life in the cosmos. The Perseverance rover continues to pave the way for future discoveries, and as we watch its journey unfold, it ignites our curiosity and fuels our imagination. With every sample collected, we are one step closer to answering the age-old question: are we alone in the universe? Stay tuned as we continue to uncover the mysteries of Mars, exploring the rich tapestry of life that may exist beyond our planet's shores. Who knows what wonders await us just around the next Martian ridge? The Perseverance rover has been on an incredible journey exploring the Martian surface for over 2 years, and it has stumbled upon something that could reshape our understanding of life beyond Earth. In fact, the discovery of potential biosignatures, organic molecules that may indicate past life, has sent ripples of excitement through the scientific community. This revelation completely changes how we understand what life could look like in the universe. And here's what scientists have actually discovered. The Perseverance rover has been equipped with state-of-the-art instruments designed to analyze the Martian soil and rock samples. One of its key tools, the scanning habitable environments with Raman and luminescence for organics and chemicals, SHARELOC, is specifically designed to detect organic compounds, including those that could be associated with ancient life. But what exactly do these biosignatures tell us, and how do we interpret them in the context of Mars's history? Let's start with the first point, the significance of biosignatures. One of the oldest debates in astrobiology has revolved around the definition of life itself. What constitutes a living organism? Historically, life on Earth was categorized based on observable traits like metabolism, growth, and reproduction. However, as we probe deeper into the cosmos, we must expand our definitions to encompass potential alien life forms that may defy our Earth-centric perspective. When Perseverance identified organic molecules in Jezero Crater, a location that once housed a massive lake about 3.5 billion years ago, scientists began to contemplate the implications. The rover detected carbon-based compounds within the sediments that formed in this ancient lakebed. The presence of these compounds could suggest that Mars was once home to conditions suitable for life. But a crucial question remains. Are these molecules indeed biosignatures? Or are they simply the result of abiotic processes, such as volcanic activity or hydrothermal vents? This brings us to an important scientific methodology, the process of elimination. Researchers use a variety of techniques to distinguish between biological and non-biological sources of organic compounds. In the case of Earth, we have extensive data and a rich fossil record that provide context. For Mars, however, we lack direct biological evidence to compare against the organic signals detected. This has led to innovative experimental designs and comparisons with extreme environments on Earth, such as hydrothermal vents and icy deserts, where scientists study how organic molecules can form without the involvement of living organisms. As we dive deeper into the findings from Perseverance, it's crucial to mention the concept of ancient knowledge juxtaposed with modern discoveries. For centuries, civilizations have contemplated the existence of life beyond our planet. Ancient philosophers like Aristotle pondered the possibilities of extraterrestrial life, while cultures across the globe infused their mythology with cosmic elements. The Aztecs, for example, revered celestial bodies and believed in otherworldly beings, while the Greeks spoke of gods who descended from the stars. Modern science is beginning to connect these ancient narratives with emerging evidence. For example, recent studies have shown that extremophiles, organisms that thrive in extreme environments on Earth, can survive harsh conditions that resemble those on Mars. This suggests that if life did arise on Mars, it could have been far different from anything we know today. This perspective not only deepens our understanding of life's resilience, but also highlights how historical narratives about life can inform our scientific inquiries. So how do we ensure that our interpretations of these biosignatures are grounded in scientific rigor? The answer lies in the methodologies employed by astrobiologists. They meticulously analyze samples returned by spacecraft, using spectrometry and chromatography to identify the molecular structure of potential biosignatures. In addition, they compare the isotopic composition of carbon compounds to discern whether the carbon had biological origins. This kind of analytical precision allows scientists to build a robust case for or against the biological significance of Martian organic molecules. As exciting as the prospect of discovering life is, it's equally important to address common misconceptions about what this means for our understanding of the cosmos. For instance, many people assume that the discovery of biosignatures automatically implies the existence of complex life forms like animals or plants. In reality, the finding of organic molecules could also point to microbial life, which might have existed in a simpler form. It serves as a reminder that life can take many shapes and forms, and that complexity isn't a prerequisite for biological activity. Furthermore, it's essential to recognize that the search for life isn't just a Martian endeavor. It's part of a grander exploration of our solar system and beyond. The methodology used on Mars is being applied to the icy moons of Jupiter and Saturn, such as Europa and Enceladus, which are thought to harbor subsurface oceans. The inquiry doesn't stop at Mars. It expands into the depths of our own solar neighborhood and reaches out toward exoplanets in distant star systems, where conditions may be ripe for life as we understand, or even as we don't. This interconnectedness of our search for life opens up fascinating scientific patterns. For example, the study of extremophiles on Earth has led to a better understanding of the potential conditions for life elsewhere. Microbial life found thriving in Antarctica's subglacial lakes or at the depths of the Mariana Trench provides vital clues about how life might exist in similar environments on other celestial bodies. Each discovery feeds into the larger narrative, highlighting not only the incredible adaptability of life, but also the common threads that unite organisms across the universe. Moreover, let's not forget the cultural practices that have historically been shaped by our understanding of the cosmos. Ancient societies often performed rituals tied to celestial events, reflecting their connection to the universe. The same sense of wonder motivates modern scientists as they explore Mars. The excitement around potential biosignatures isn't just about what we might discover. It's about our innate desire to understand our place in the cosmos, a quest that has transcended time and cultures. As we continue to analyze the data sent back from Perseverance, we stand at the precipice of potentially rewriting our understanding of life in the universe. Each sample analyzed, every organic molecule detected, and each layer of Martian rock examined brings us closer to answering the question, was there ever life on Mars? And if so, what does that mean for the broader tapestry of life's evolution across the cosmos? The discoveries from Mars echo back through history, connecting us to our ancient ancestors who gazed at the stars and marveled at the possibility of life beyond their own. The alignment of these two narratives, the ancient and the modern, fuels our curiosity and propels scientific inquiry forward. Each new piece of data serves not only as a potential clue to the past, but also as an invitation to rethink what life could be. While we await further analysis and perhaps the eventual return of Martian samples to Earth, the Perseverance rover's findings serve as a reminder that the quest for understanding is ongoing. Just as ancient scholars used the knowledge of their time to make sense of the world around them, modern scientists are now applying advanced technology and methodologies to unlock the mysteries of Mars. In doing so, they are not only searching for signs of life, but are also exploring the very nature of existence itself, a question that has perplexed humanity since the dawn of time. As we reflect on what we've found so far, each discovery becomes a stepping stone towards a greater understanding of our universe, one that inspires awe and wonder, just as it did for those who came before us. Looking ahead, the implications of these discoveries are profound. If biosignatures are confirmed, we might need to rethink our approach to astrobiology and the criteria we use to define life. It could lead to the development of new technologies and methods to explore further, not only Mars, but other celestial bodies as well. The cosmos is vast, and the possibilities are tantalizing. In this extraordinary journey of discovery, we find ourselves not just as observers, but as participants in the unfolding story of the universe. With each new finding, we're reminded that the search for life is as much about understanding ourselves as it is about uncovering the mysteries of distant worlds. And perhaps, in the end, it is that very quest for understanding that binds us as humans to the greater cosmos. As we continue to unlock the secrets of Mars, let's keep our minds open to the wonders yet to be revealed. For history and science are constantly intertwined, a narrative that continues to unfold. Much like the layers of sediment on the Martian surface, waiting for us to dig deeper and discover the stories they hold. These insights not only excite our imagination, but also challenge us to question our place in the universe, inviting us to explore with a sense of wonder and curiosity. The journey is far from over. In fact, it's just beginning. So stay tuned, because there are many more revelations to come as we navigate the rich tapestry of scientific discovery and the ancient stories that guide our exploration of the stars. Imagine this: the Perseverance rover has just discovered potential biosignatures on Mars, suggesting that life might have existed on the red planet. This revelation doesn't just spark excitement about extraterrestrial life, it completely reshapes how we perceive the history of life on Earth and beyond. Here's what scientists actually discovered. As Perseverance traversed the dusty Martian surface, its instruments began to analyze rocks and soil. One of the most groundbreaking findings came from the rover's analysis of ancient lake beds, which hinted at the presence of microbial life. This discovery is monumental, as it introduces the possibility that life, albeit in microbial form, not only evolved on Earth, but also flourished elsewhere in our solar system. The implications of finding biosignatures are profound. To understand why, let's first delve into what biosignatures are. These are indicators that suggest past or present life. They can be chemical, physical, or biological features. The detection of organic molecules, for instance, could signify that ancient organisms once thrived in Mars' life-sustaining waters. This opens up fascinating avenues of inquiry, compelling scientists to reconsider how we interpret the conditions necessary for life. But hold on, these findings challenge a popular misconception that life can only exist under Earth-like conditions. We often think of life as something that requires oxygen-rich atmospheres or particular temperature ranges. However, the discovery of extremophiles here on Earth, organisms that thrive in the harshest environments, from boiling hydrothermal vents to freezing Antarctic ice, tells a different story. These hardy life forms reveal that life can adapt in unexpected ways. If life can endure such extremes on our planet, why couldn't it do the same on a planet like Mars? Transitioning back to Mars, let's consider the scientific methodologies employed by the Perseverance team. One of the rover's key tools is its suite of spectrometers, which analyze the mineral composition of Martian rocks. By utilizing infrared spectroscopy, scientists can identify specific molecular signatures that may suggest biological activity. It's like having a remote laboratory on another planet, unlocking the secrets of Mars without ever setting foot on its surface. Crucially, these biosignature analyses also draw connections to ancient Earth. For instance, when examining sedimentary rock formations that preserve evidence of ancient microbial mats, known as stromatolites, scientists can see parallels between the processes that occurred billions of years ago on Earth and those that might have happened on Mars. Such patterns pique our curiosity about the universality of life itself. Are the conditions that fostered life on Earth replicated elsewhere in our solar system? Moreover, modern science allows us to scrutinize and reinterpret historical narratives. For centuries, humanity has pondered the question of life beyond Earth. Cultures across the globe have woven tales of celestial beings and otherworldly encounters. Ancient texts and mythologies often reflect a deep-rooted curiosity about our place in the universe. By analyzing these cultural practices through a scientific lens, we can bridge the gap between ancient knowledge and contemporary discoveries. For example, consider the ancient Greeks, who theorized about the existence of other worlds. Their musings might seem whimsical, yet they laid the groundwork for future explorations. Fast forward to today, and we are using advanced robotics and artificial intelligence to explore those very celestial bodies they speculated about. It's as if their curiosity has echoed through the ages, culminating in the technological marvel that is the Perseverance rover. The connections between early philosophical inquiries and modern scientific endeavors are not just anecdotal. They reveal a fascinating pattern of human thought. For centuries, we have looked to the stars, contemplating our existence and the possibility of life beyond our planet. From the heliocentric model proposed by Copernicus to the discovery of exoplanets in the habitable zone of distant stars, each advancement has brought us closer to answering the age-old question, are we alone? But as we celebrate these scientific milestones, we must also acknowledge the challenges that lie ahead. The search for biosignatures on Mars isn't without its pitfalls. Skepticism abounds, particularly regarding the interpretation of data. Researchers must meticulously rule out abiotic processes, those not related to life, that could mimic biosignatures. For example, certain chemical reactions can produce organic molecules, leading to potential misinterpretations of the data. This caution is crucial, as it ensures that we build our understanding on a solid scientific foundation, rather than jumping to conclusions based on tantalizing yet inconclusive evidence. In light of these complexities, the Perseverance rover's findings must be viewed as part of a broader tapestry of research. The ongoing collaboration between planetary scientists, astrobiologists, and geologists enriches our comprehension of what it means to seek life on other worlds. Each piece of evidence gathered adds to a collective narrative, reshaping our understanding of life, both past and present. As we draw connections from Mars back to Earth, let's consider how ancient civilizations responded to their environments. Just as the Perseverance rover analyzes Martian soils, the signs of life, ancient peoples observed their surroundings and adapted to them. For instance, the ancient Egyptians harnessed the Nile River, cultivating crops and developing a sophisticated society. Their reverence for the river's life-giving properties speaks to a deep understanding of the connection between water and existence, a fundamental principle that resonates with our search for life on Mars. In parallel, recent archaeological discoveries have illuminated how ancient cultures interacted with their environments, often leaving behind rich narratives embedded in the earth. The ruins of long-lost civilizations are like time capsules, offering glimpses into how societies adapted or failed to adapt to changing climates. These findings, much like the biosignatures on Mars, force us to reassess our understanding of resilience in the face of adversity. The scientific methodologies used to study these ancient sites reflect a meticulous approach akin to that of the Mars rover mission. Archaeologists employ techniques such as carbon dating to ascertain the age of artifacts, while geospatial technologies allow for detailed mapping of excavation sites. Similarly, rovers and landers equipped with high-resolution cameras and spectrometers analyze Martian terrain, creating a dialogue between past and present. In recent years, the discovery of ancient microbial life preserved in Earth's rock strata has illuminated the conditions that fostered life on our planet. These findings act as a backdrop to our Martian pursuits, suggesting that the early Earth was a dynamic environment, rich in the ingredients necessary for life. The idea that Mars might share a similar past encourages scientists to look beyond our own planet and consider the fluidity of life's potential across the cosmos. What's equally enthralling is how these ancient Earth discoveries inform our understanding of astrobiology. The fossil record, often viewed as a linear progression of life, opens up discussions about the adaptability and resilience of organisms. Just as ancient life forms responded to environmental changes, the search for extraterrestrial life asks us to consider how life might adapt in alien conditions. The interplay between ancient biosignatures and Martian potential creates a mesmerizing storyline that transcends time, demonstrating a shared narrative of survival against the odds. Now, let's pause and reflect on the wonder of it all. Think about the vast expanse of the universe and our small yet significant place within it. The Perseverance rover is not merely a machine navigating the Martian surface. It symbolizes humanity's relentless pursuit of knowledge. Every rock it analyzes, every spectrograph it sends back, expands our understanding of life's possibilities. But before we rush to make proclamations about the existence of life on Mars, let's consider the broader implications. What does the search for life on another planet say about our own existence? Are we merely products of a series of fortunate cosmic events? Or is there a deeper purpose we are yet to uncover? The questions that emerge from these explorations echo throughout history, resonating with the inquiries of ancient civilizations who gazed at the stars in wonder. As we delve deeper into this narrative, let's not overlook the technological marvels that have made our journey possible. The innovations that power the Perseverance rover, advanced robotics, artificial intelligence, and state-of-the-art imaging technology, are a testament to human ingenuity. Each development is built upon the knowledge of generations past, showcasing a lineage of scientific inquiry that stretches back to the dawn of civilization. In revealing the secrets of Mars, we are not only seeking to understand another planet, we are simultaneously uncovering layers of our own history. The discoveries made by Perseverance can influence our perspective on climate change, ecosystem resilience, and the future of life on Earth. The lessons learned from Mars could one day illuminate paths to sustainability and resource management in a rapidly changing world. As we continue to explore the cosmic tapestry woven from both ancient and modern threads, it becomes increasingly clear that our quest for knowledge is intertwined with an inherent desire to understand our place in the cosmos. The search for life on Mars is not just about finding extraterrestrial organisms. It's about understanding the very essence of life itself, its origins, its adaptability, and perhaps its fate. In summary, the Perseverance rover's discoveries are igniting a scientific renaissance, compelling us to examine the connections between ancient life on Earth and the potential for life on Mars. With every revelation, we are drawn deeper into a narrative that transcends mere exploration. It invites us to reconsider what it means to be alive, to adapt, and to thrive in an ever-evolving universe. As we continue this incredible journey, stay tuned to witness how our understanding of life, both on our home planet and across the cosmos, continues to evolve. But before we delve even further, let's take a moment to appreciate the wonder that surrounds us. Science isn't just about facts and figures. It's about the stories behind them. It's about the relentless human spirit that drives us to ask questions and seek answers, illuminating the path for future generations. Now, speaking of illuminating paths, if you're fascinated by the ongoing discoveries from Mars and the implications they hold for our understanding of life, make sure to stay with us for the next part of this series, where we'll explore more about the technological advancements that have made this exploration possible and the cultural implications of our cosmic discoveries. We've only just scratched the surface of this incredible story. As we approach the conclusion of our exploration into the biosignatures found by the Perseverance rover on Mars, let's take a moment to reflect on the profound implications of these discoveries. The evidence gathered thus far has not only illuminated our understanding of Mars, but has also cast a shimmering light on the potential for life beyond our home planet. One of the most striking findings from Perseverance's mission has been the identification of organic molecules in the Jezero Crater. These molecules are often regarded as the building blocks of life, and their presence on Mars raises tantalizing questions. Could they be remnants of ancient Martian life forms? Or are they simply the result of non-biological processes? The debate is further fueled by the rover's ability to analyze the geological context of these biosignatures, providing insights into the environment in which they were formed. What's fascinating is how these discoveries create a bridge to our understanding of life so far. A team of scientists led by Dr. Jennifer Eigenbrode has confirmed that certain carbon-containing compounds, specifically organic molecules, have been found in the Martian soil and rock samples. These compounds are similar to those found in extremely ancient Earth rocks that date back to the time when life was beginning to emerge here. This comparison tantalizes us with the idea that Mars may have had similar conditions for life billions of years ago. Moreover, the rover has been equipped with the ability to analyze the isotopic composition of these organic molecules, which can provide clues about their origins. For example, the ratios of carbon isotopes can indicate whether these compounds were biologically produced or formed through geological processes. This kind of detailed analysis opens up a new frontier in astrobiology, allowing scientists to piece together the environmental history of Mars in a way that was previously unimaginable. Transitioning from the findings of Perseverance, let's consider the implications of these discoveries in a broader context. The possibility of life on Mars not only reshapes our understanding of the planet itself, but also prompts a reevaluation of life's resilience and adaptability across the cosmos. The ancient Earth was a tumultuous place, rife with volcanic activity and unpredictable climatic shifts. Yet, life thrived, adapting to even the harshest of conditions. If life could emerge and evolve on a planet like Earth, could the same have happened on Mars? This leads us to consider the interconnectedness of our solar system. The recent evidence from Mars serves as a reminder of our quest for knowledge and the scientific method's unyielding promise to guide us. Each discovery builds upon the last, creating a tapestry of understanding that spans not just our own planet, but potentially extends to the vast realms beyond. For instance, think about the implications of finding biosignatures in our neighboring planets and moons, like Europa, with its subsurface ocean, or Enceladus, stewing geysers of water vapor, rich in organic compounds. The scientific community is abuzz with the possibility that these celestial bodies might harbor life in ways that mirror the early conditions on Earth. As we refine our techniques and technologies, our capacity to explore these worlds only broadens, fueling our curiosity and ambition. However, the journey does not come without its challenges. The biosignatures we've observed on Mars are but one piece of the puzzle. The scientific method is rigorous, and our interpretations must be scrutinized and validated through further research. The excitement that comes from discovery must be tempered by a commitment to precision and skepticism. For in science, it's not merely about what you find. It's about understanding what those findings mean in the grand narrative of our universe. In light of this, let us not overlook the profound questions that these findings provoke about our place in the cosmos. The search for extraterrestrial life is arguably one of humankind's greatest endeavors. It compels us to look at our own existence through a new lens, challenging us to consider whether we are unique or part of a much larger, interconnected tapestry of life across the universe. The very act of exploring our celestial neighbors serves as a unifying force, bringing together scientists, engineers, and dreamers from all corners of the globe. As we reflect on all we've learned from the Perseverance rover, we recognize the strides we've made in our understanding of our solar system. Yet, we are also acutely aware of how much more there is to discover. The next chapters in our quest to unravel these mysteries will undoubtedly be filled with new technologies, innovative methods of analysis, and perhaps even direct evidence of life beyond Earth. In conclusion, the exploration of biosignatures on Mars not only enriches our scientific knowledge, but also invites us to engage with our own humanity. Each discovery sparks a sense of wonder that is deeply rooted in our intrinsic desire to understand the world around us. The evidence we gather today acts as a beacon, guiding future generations in their quest for knowledge. It reminds us that the universe is replete with mysteries waiting to be unveiled. And as we journey through this vast expanse, we are part of something far greater than ourselves. The Perseverance rover's mission encapsulates the spirit of exploration that defines us, an insatiable curiosity, a relentless pursuit of truth, and an unwavering hope that we may one day find our cosmic kin. So, let us continue to dream, to explore, and to ask the most profound questions. What else is out there? And perhaps, most importantly, what does it mean to be human in a universe that is full of possibilities? With each discovery, we take one step closer to understanding the complex web of life that may extend beyond our planet. And in doing so, we illuminate our own path through the cosmos. The journey continues, and who knows what wonders the next mission will unveil. Until then, keep your curiosity alive, for it is the fuel that drives our exploration of the unknown.